Very good morning, guys. In today's session, we will see about textile industry. So, under this session, we will see what is the manufacturing process that is undergoing in textile industry. What are the characteristics of wastewater that is coming out from the textile industry and where does it comes from, as well as its effects and treatment. So, we'll see one by one. So, this is the manufacturing process what has been happening in the textile industry. The cotton bales, once it is received in the textile industries, it will be subjected to opening and cleaning. So it will be done in a machine where called a opener, so that the bales will be get opened up. Then it will be taken to the picking unit. Actually, in picking unit, it will be beaten with some beater so that it will be get loosened up and all the impurities like seeds and everything will be get removed from here. Then it will be taken to the cording unit where it will be get it will be get into line up as thin threads so that it can be easily spinned up. So that is what done in the cording unit. Then it takes to the combing unit. See, combing unit is actually optional one. It is done to remove the short fibers as well as to strengthen the yarn. Then it is taken to the drawing unit where your final thin spread of your thin threads will be formed. Then it will be taken to the spinning units. It will be get spinned up into the bobbins. Then it will be taken to slashing, weaving and knitting units. So where that final your weaving cloth will be formed. Okay, this is actually these are all the dry process what is happening in the textile industry. So when you come to the wet process, you will be having desizing, scoring, bleaching, mercerizing, dyeing, printing, finishing and packing. Actually, these are the units which is going to constitute the wastewater from this textile industry. So these are the units which are going to give you the wastewater that is out of this all the processes. So before going into deep into this, we will see what is this wet process. So we have the sizing, desizing, scoring, bleaching, dyeing, finishing and finished product. So this are the process which is going to contribute to that of your wastewater out of this all the treatment process in this treatment textile industry. So this is the treatment manufacturing flow chart what is shown once again of the cotton textile mill, where we have specified the what are the chemicals it is used in the process also. So we will see in deep one by one later. So the entire liquid waste that comes from this textile industry, as we saw, it is from this operations, that is your slashing, scoring, desizing, bleaching, mercerizing, dyeing and finishing units. So if we take as a whole in a textile industry, so where does this the main source of wastewater that arise from this is, one is in the preparation of the yarn slashing process. That is a process where we will be getting the major amount of wastewater. And apart from that, in textile processing, as we saw in desizing, keying is a scoring process, and bleaching, mercerization as well as dyeing and printing will be getting the major amount of wastewater. And apart from that, if there is any washing operations in the textile process, we will be getting the wastewater from that units. And miscellaneous waste streams, which will be including the cooling waters as well as the boiler blowdown and housekeeping waters, that is it includes floor washing as well as the washing of equipment. Apart from that, if there is any accidental spills and leaks, that will also contribute to the wastewater. And finally, the sanitary waste that is coming out of the textile mill. So these are the main sources of wastewater that is coming out from the textile industry. So this is your picking unit. As I already said, once a cotton bale is received in this textile industry, first it will be get opened up with the help of a opener. Then it will be taken to the picking where it will be beaten with some equipment, it will be get beaten so that the cotton will be get loosened up and all the impurities and seeds can be easily removed off. Then it will be taken to the cording process where these fibers will be made into thin form so that it can be easily get spinned off. So this is a combing process. As I already said, combing is optional. That depends upon the industry. It is just to remove the shortened fibers as well as to increase the strength of the yarn. And finally comes your spinning unit where the threads will be get spinned up and it will be taken into that of the bobbin. So this is the process what we have discussed. So we will discuss that in detail. As I already said, once the bale is received in the textile industry, it will be broken up with a machine with large spikes, that is called the open air. Then after that, that cotton will be taken to the picking unit, where the cotton will be beaten with a beater bar in order to loosen it up. Then it will be taken to the cording unit, where it will be line up the fibers. That is, the fibers will be drawn into thin lines so that it is easier to spin, as I already told you this. And combing is optional, but it is used to remove the shorter fibers as well as creating a stronger yarn. And drawing is a process where the fibers are get straightened up. And the spinning machines is the spinning is actually, that it is where the fibers will be get thin, and it will be get twist, and it will be created into yarn, which will be winded onto the bobbin. So what is the winding processes? In case of winding process, that cotton thread will be winded up. It will be taken to the required length, as well as it will be winded up into the bobbins. And the next unit in your textile industry is your warping or beaming process, where one or two threads more than this, it will be get combined together so that the desired thread count can be done, and it will be get warped together. And this is the other unit what is there in the textile industry, as we saw in the manufacturing process, so that is sizing. So in this case of sizing, the machine, that cloth will be get strengthened by adding starch, so that it will be reducing the breakage of the yarn, so that we will get a continuous fiber. And desizing is operation where this cloth will be, depending upon the cloth size, it will be subjected to the dilute acid, as well as it will be get rinsed with that of the other enzymes, so as to break down the required size. And next important process is your slashing process, where the yarn will be get strengthened with the help of starch or carboxylic cellulose or other sizing agents. Earlier they were using starch for strengthening it up, but nowadays we are using with carboxylic cellulose, because when we use starch, the amount of BOD that is contributing in that of the wastewater is very high. So nowadays we are going with that of your alternative sizing agents like carboxylic cellulose, so that the BOD contribution from this industry will be get reduced. And this is the next process, coring process. Normally this coring process is otherwise said to be a curing process, where caustic soda or soda ash or detergents will be added in a care boiler, and the cloth will be subjected to boiling, so at high temperatures, so that what happens is it removes the natural wax as well as the non-fibrous impurities from this. As this care boiler is a closed one, so that the oxygen will be excluded, and this will be also helpful in degrading the cellulose in the fiber. And the next process is your bleaching process, where we use oxidized chemicals like peroxides and hypochlorites. As the name it implies, we are going to remove the natural coloring material, so that the entire cloth will be turned up into white, and the degree of bleaching will be depending upon the required whiteness as well as the absorbency what is required by the manufacturer. And mercerizing is the next unit in the textile industry. So here this entire cloth will be passed to 30% caustic soda solution, so that it will be improving the strength as well as the elasticity, leisure and dye affinity in the cloth. And here the waste from this section, it can be recycled after we get the sodium hydroxide recovery. And singeing is a process where all the surface fibers in the fabric will be get burned off, so that it will be getting will get a smooth fabric. For this the fabric will be processed over the brushes to raise the fibers, then it will be processed over a plate heated by gas flume, so that all the surface fibers will be get removed. And as I already said, caring is an important unit in this boiler, in the textile industry, which is contributing to the most of the wastewater. So in this caring process, we have already seen that the cloth will be get boiled, so that it will be removing the grease, wax, natural fats as well as the other impurities, by passing this cloth to that of 1 to 3% of caustic soda, soda ash, sodium silicate, sodium peroxide or any other chemicals for several holes with the aid of the stream. So this caring can be done either in batch process, or it can be depending upon the industry, it can be also on the continuous process. And this is a major amount of wastewater that is coming out from the entire textile industry. So large volume of wastewater is coming only from this of the caring industry as well as caring unit, as well as it requires a large volume of water for processing also. So after this, the final stage is your dyeing process, where we'll be having different types of dyes, as it is shown here: VAT dyes, developing dyes, naphthol dyes, basic dyes, sulfur dyes, direct dyes, and indigo dyes. That depends upon what is our requirement. We'll use any of these dyes. Usually what is the process is, first that certain materials will be added to reduce the dye, then it will be oxidized so that it will be get attached with that of your fabric. So in case of wet dyes, caustic soda and sodium hydroxide are used as reducing agents, while oxidizing agents will be peroxides and chromates. In case of developing dyes, acids and sodium nitrate will be used, and then it will be treated with a developer. And in case of naphthol dyes, the dyes will be get applied, dried, and it will be passed through the developer. Similarly, in case of sulfur dyes, we will be getting sodium sulfate and chromate. So we will see this one by one. And indigo dyes is similar to wet dyes, but it requires only air oxidation. So in case of direct dyes, from the name itself you could say these are the natural substances. They are applied to the fabric without any moderns. They are easy to apply, and it is light, as well as they are stable for washing also, so they will not get easily washed out. And basic dyes, these are also the neutral substances of color base. Okay, and it will be applied along with it of the tannic acid, followed by tartar emetic. So these dyes are noted for their bright colors. And wet dyes, already we have seen, it will be added with the sodium hydrosulfide and alkali. So that will be then, and the fabric will be washed at the end of each operation after finishing this dyeing. And sulfur dyes also we have seen, it is done with a reducing agent like sodium sulfide followed by oxidation. See, normally this dyes will be get reduced, then it will be get oxidized, so that it will be get impregnated onto that of the fabric. In case of naphthol dyes, the color will be developed by two-stage process consisting of treatment with beta naphthol as well as diazotization, that is followed by hot soap as well as caustic soda. And developed dyes, in this case, the dyeing will be carried out in a reverse manner. That is, the color will be first directly applied to the fabric, and then it will be treated with sodium nitrate and acid to convert it into the unstable azo dye. Next, the stable form of the color is developed to the fiber by the action of bentonol. So this is the case of your developing dyes, which is the reverse of what are the other dyes we have used up. And yarn is also be can dyed up from this. So in this mills, yarn will be dyed depending upon the requirements. So initial scoring will be done, followed by bleaching, and then will be dyed with it of the required dye liquid. Otherwise any other finished colors we can be used for this. Okay, then this will be followed with it of the scoring process with detergents and soap. So either we can dye the entire cloth, or we can dye the yarn. That depends upon the industrial requirements or the consumer requirements. So after this, once the dyeing is fixed and the thickened dyes along with the printing gums, it will be sending for the printing and fixation, so where it will be get printed up, and then fabric will be washed to remove the unfixed dyes. And finally, in finishing process, finishes like starches, dextrins, natural and synthetic waxes, synthetic resins are used, so that the colors and the finishes will be get firmly sticked on to this cloth. So what is the effects when we dispose such industrial wastewater, textile wastewater into that of your streams? Except your dyeing industries, if you are going it up, dyeing unit alone, we could see that the textile mill effluent, it will be causing the rapid depletion of dissolved oxygen. So once the dissolved oxygen is get depleted, when we dispose of such effluents into that of your stream, what happens that is, it will be affecting your aquatic life as well as the flora and fauna. And apart from that, the sulfides and chromium, what is present in this textile effluent, it will also affect the aquatic life. And if the dyes are disposed of, they are toxic, and they will be rendering the entire stream unfit for use, as well as not only in terms of color but also in terms of usage also, and it causes the killing of the aquatic life and other organisms. And sulfides, if it is present here, it will be making the water corrosive, very particularly if we use this water for the concrete structures. So these are the effects when we render this wastewater into that of your stream. So this is the wastewater characteristics what is coming out from this each of the units. As I already said, the sizing, desizing, scoring and bleaching, mercerization. So this are the wet process which is going to contribute to that of your wastewater in the textile industry. So when you could see in the sizing unit, you will be having the high BOD as well as medium COD. And when you come for desizing, you could see the enzymes, starch, waxes and ammonia are used as a constituents, and you will be getting the BOD, high COD as well as temperature. And in case of scoring units, you will be getting oily fats, BOD, high temperature, etc. And you could see the constituents along with the wastewater characteristics also. So in bleaching, you will be getting high pH TDS. So when you come for the dyeing unit, this is a major polluting area in the industry. Where you will use color, metals, sulfide, salts, acidity, alkalinity or formaldehyde in the dyeing process. As a result, the wastewater which is coming from this, it will be having high toxicity and high BOD, high dissolved solids as well as high pH. That's why nowadays in most of the textile industries, we will be having dyeing units separately as well as other processing units separately. And in certain other units, industries, we don't have dyeing operations at all because it's contribute to the maximum amount of wastewater pollution. So these are the characteristics of typical cotton textile mill waste. Where you could see the pH is 9 to 10.5, that is in the alkaline range, and total alkalinity is 600 milligram per liter, and BOD is high 900 milligram per liter, and the color is also brown color. Then that depends. This is like I was saying you for the typical cotton textile mill. If it is of comprising of dyeing units also, then the color will depends upon the dye what we apply. And total solid is 3000 milligram per liter, and total chromium that is coming from this is 4 milligram per liter, and suspended solids is 100 milligram per liter. And these are the characteristics of typical woolen textile mill waste. You could see here the BOD is 760 milligram per liter, whereas the COD is 1418 milligram per liter, and total chromium compared to that of your cotton textile mill waste. In case of woolen textile mill waste, it's higher, it's of 12.5 milligram per liter. And these are the characteristics of the process wastewater streams from that of the textile mills. We could see here the desizing units, the wastewater volume is very small, and in curing units also it's very small, but we could see not only the volume is strong, but when you see the characteristics, that is your strength, it will be high in case of your curing units as well as in your desizing units. And similarly in your mercerizing units, though it is small, that it will be strong in strength. And in case of your dyeing units, it will be having large and it will be strongly colored also. So that is very difficult to treat. And in case of printing, it will be having highly colored because it also gets washers from this after dyeing process, as well as printing gums. And it will be having high BOD as well as oily appearance also is there. And in the finishing process, it will be having a very small wastewater with of slightly alkaline low BOD. So these are all the characteristics of the process waste streams that is coming out from the textile mill. So when you go for the treatment, if it is a treatment of a cotton textile mill waste, is a typical treatment that is given. So where the raw wastewater, except the dyeing wastewater, it is sent to the equalization tank, neutralization tank, coagulation tank, then settling, and HRTF is your high rate trickling filter, as you know. Then it is taken to SST, that is secondary settling tanks, then finally to that of the sand drying beds. So as we know, in equalization tank, it will be get equalized, so that if that depends upon the industrial process, if whether it is continuous mode or intermittent mode, so it has to be get equalized. Then it will be taken to the neutralization tank, where the specific chemicals will be added to neutralize into the normal pH. So here H2SO for sulfuric acid is added because the pH of this textile industry is in the alkaline range. So we are adding the acid so that it will be get neutralized. Then it will be taken to the coagulation tank, where the coagulant is used, NaSO4 thrice is used, so that all the substances will be get coagulated and flocked, and it will be get settled down in the settling tank. And further it will be taken to the trickling filter. So any other secondary settling treatment process depending upon the industry, then it will be taken to that of the sand drying beds. So when you see the treatment of cotton textile mill waste, wherever it is possible, it is advisable to get the recovery, not only in a textile industry or in whatever the industry, that is the main aim of the industry. So here also we could get the caustic recovery from the carrying up division as well as mercerizing divisions using dialysis, so that it will be reducing the pollution to the great extent. And apart from that, the dyeing waste that can be treated economically by using biological methods with prior equalization, neutralization as well as chemical oxidation. And sometimes extended aeration is also be giving a better results, which will eliminate the sludge digestion also. So these are the normal dyeing wastewater treatment process what has been advised to the industry. So where we can have physicochemical water treatment process and biological water treatment process, or the combination of this also we can be done, and cutting edge treatment process where you get photochemical oxidation, electrochemical oxidation, ultrasonic technology and high energy physical process can also be done for the textile industries. As we already see, so the recovery we can do recovery of your sizing agents like carboxymethyl cellulose, because earlier, as I said earlier, they were using starch and it contributes a major amount of BOD in the wastewater. So nowadays we are using with the sizing agents like carboxycellulose, which will be reduce the BOD content also, and it can be easily recovered also. So that is there. And caustic recovery from this mercerizing water as well as from the carrying waste, that can be done by using dialysis. And even the recovery of dyes can also be done. So in the case of wet dyeing process, about 65 to 75% of the dye which is absorbed by the fiber, and the rest will be get drained out. So that can be easily recovered as well as it can be reused also. Similarly, bright colored lakes, lacquers etc., it can be recovered from the basic as well as reactive dye waste liquors just by precipitation of the metallic derivatives. So the other case of reducing your pollution load is reduction of your waste load by using either substitution of process chemicals or by applying process modifications. So if any of the industry it concerns, the major process to reduce waste is first one is segregation of the wastewater. As we already see, what is that is we have to segregate as large volume wastewater which is having less pollution load, as well as small volume of wastewater which is high in pollution, so that only that small volume which is high in pollution can be easily treated with it of the advanced treatment methods what we have seen. After that segregation, we can go for finding out what is the recycling and reuse operation inside this textile mill or whatever the industry it is. Then next one is we should see what is the possibility of recovery as well as reduction. That's why we used to say that 4 R's is very important for any industry. So starting from reduction, reuse, recycle as well as recovery. So when you go for reduction, we can go for substitution of process chemicals. So that will be reducing a large contribution of BOD into that of your wastewater. So that's why we could already told you that instead of carboxycellulose, we can use carboxymethyl cellulose as well as polyvinyl alcohol instead of starch, because starch is constituting a high amount of BOD. So instead we can go for carboxymethyl cellulose and polyvinyl alcohol, so that the BOD amount load will be get reduced up to 50%. It's a good amount. And process modifications, we can make a small use of process modifications so that we can use with a high speed machinery with alternative process chemicals, so that will be reducing the pollution load. So that this process modifications usefully we should see that it should not contribute to the major amount of capital cost to the industries. Otherwise the industries will not easily adapt it, so that we could go for minor changes in the process so that it will be easily adapted into the industry, so that final effluent will be having less BOD. Even this the soap by substituting the soap with it of the detergents, that also can be used once again the substitution of the process chemicals. So this process chemical substitution will not contribute to much of the capital cost or the operating cost, so that it can be easily been adapted by the industries. By the process modification, where the replacement of machinery or changes in the machinery, we have to take it in a serious case that it should not cause some high capital cost. So with this we will end up with the textile industry, and in the next section we will see about paper industry. Thank you guys.